We're surrounded by huge challenges, things like polluted water and dirty air. But what if I told you that one of the most powerful tools to fix them was literally shining down on us every single day? Today, we're going to break down the science of photocatalysis and how simple sunlight can be harnessed into a truly remarkable cleaning tool. I know, it sounds a little bit like science fiction, doesn't it? Can sunlight, the most abundant energy source we have, actually be used to clean our planet? Well, it turns out the answer is a big yes, and it lies in some absolutely fascinating science that we're about to dive into. So, the key to this whole sun-powered solution is a process called photocatalysis. Imagine for a second that you could use light to kickstart chemical reactions, turning totally ordinary materials into super-powered purifiers. It's an incredible way to tap into the power that's been hidden in sunlight all along. Okay, so at the very heart of this process is a special material, a photocatalyst. Think of it like a matchmaker. It uses the energy from light to get pollutants and clean substances to react, transforming the bad stuff into harmless things like water and CO2. And here's the best part. The catalyst itself doesn't get used up. It can do this job over and over and over again, powered only by light. All right, so how does this magic actually happen? I mean, how can a simple material and a bit of light actually clean up our environment? Let's get right into the fundamental principle. When you boil it all down, the core idea is surprisingly simple. You take a semiconductor, and yes, I mean the same kind of material that's inside your phone right now, and you shine light on it. That light energy gets absorbed, and it becomes the fuel for a powerful chemical reaction right there on the material's surface. The whole thing can be broken down into a kind of 5-step recipe. It kicks off with absorbing light and ends with a finished product, say clean water or purified air. Now, some of these terms might seem a little technical, but stick with me, because the idea behind it all is super elegant. Let's walk through it. Okay, this is where we really get into the how. Let's pull back the curtain and look under the hood at the incredible physics that unlocks all this power inside the semiconductor material itself. All right, to really get this, I want you to picture a 2-story parking garage. The bottom floor, that's called the valence band. All the cars, which are our electrons, are parked down there. They're stable, they're content, they're not really going anywhere. Then you have the top floor, the conduction band. It's totally empty, just a wide open space representing a much higher energy level. So then, bam, a photon of light, which is just a little packet of light energy, comes flying in. Think of this photon as a valet key. It gives one of those cars, one of our electrons, just enough juice to suddenly zip up the ramp and move to that empty upper level, the conduction band. This electron is now full of energy and ready to move. But here's the crucial part, the part you really gotta remember. When that electron car moves upstairs, it leaves behind an empty parking spot on the ground floor. Now, this isn't just an empty space. Scientists call it a hole, and it actually carries a positive charge. So now we've got 2 active players on the field, the super-energized electron up top and the positively charged hole down below. So what's the big deal about this electron and this hole? Well, when they move to the surface of the material, they become these little reaction engines. They create what I like to call molecular cleaning robots. The hole can rip apart a water molecule, and the electron gets grabbed by oxygen. Now, don't worry about the chemical names on the screen. All you need to know is that these things they create are incredibly aggressive particles that go around and just tear apart any pollutants they find. So we've got a process that creates these little cleaning robots powered by sunlight. That sounds amazing in a lab, but what does it actually mean for us, in the real world? Let's take a look at how this technology is actually being put to work right now. I mean, the potential here is just staggering. This isn't just one niche application. We're talking about, get this, self-cleaning windows that use sunlight to just wash away dirt, water purification systems that can break down nasty industrial chemicals, even hospital surfaces that can constantly disinfect themselves using just the lights in the room. And looking ahead, scientists are even using this to turn captured CO2 into fuel. The possibilities are absolutely transformative. Now, as promising as all of this sounds, it's not a perfect silver bullet. Well, not yet, anyway. Let's talk about the road ahead, looking at the current challenges and the really exciting research being done to create the next generation of these amazing materials. So on the one hand, the advantages are super clear. It's a green technology, it uses free energy from the sun, and it works in normal, everyday conditions.
But there are limitations. The single biggest challenge is something called charge recombination, which we'll explain in just a sec. Plus, a lot of the best materials only absorb UV light, and that's just a tiny slice of all the sunlight we get.
Okay, so let's go back to our parking garage. Remember the Electron car on the top floor and the empty parking spot, the hole down below? Well, the problem is that the Electron really wants to fall right back down into that hole. If it does that too quickly, poof, all that energy is just lost as heat. They recombine and no cleaning robots get made. So the whole game for scientists is figuring out how to keep them separated long enough to do their important work. And to solve that problem, researchers are designing some seriously clever structures. Imagine layering different kinds of these semiconductor materials together, creating a sort of internal one-way highway system for the electrons and holes. These advanced designs, with cool names like Z-scheme or S-scheme, act to force the charges apart, preventing them from just falling back together. And that dramatically boosts the overall cleaning efficiency.
You know, this quote really just sums it all up perfectly. At its heart, this entire process is about one fundamental conversion: taking the clean, abundant energy from light and turning it into potent chemical energy that can go out and solve real-world problems.
So we'll leave you with this final thought. We now have a technology that can literally turn a beam of light into a cleaning tool. We can use it to clean our water, our air, and even the surfaces we touch. The only question left is, with a tool this powerful and this sustainable, what big problem should be pointed it at next?